All right, welcome back to this video. Now that we've designed our topology, we've also assigned interfaces to the various VLAN. What you're going to do is now configure the gateways for each VLAN. So what I'm going to do, we just click on the router. When you click on the router, we have our CLI mode over here. We type no because we don't want to enter into the initial configuration. So we start the configuration. We have conft. As I said earlier on, the first gig or the first interface, which is the gig 00, is for VLAN 5, and the gig 01 is for VLAN 10, and gig 02 is for VLAN 20. So we'll start configuring our interface gig 0/0, and I'm going to assign an IP address. We have 192.168.5.1. The subnet mask 255.255.0, and we run no shutdown. See, the first gateway is up. We move to the second one. We have int gig 01/1. We have IP address. Okay, actually, with these interfaces, we can add some description. The description is just the label. So let me go back to the gig 00, sorry. I'll add description. I'll say this is the gateway for VLAN. This is the gateway for VLAN 5. Yeah. So this description is going to help the viewers actually to understand that this gateway is for this VLAN, this gateway is for this VLAN. Okay, so I'll now move to the second, which is the interface gig 0/1. Our IP address 192.168.10.1 /24, so 255.255.255.0, and no shutdown. See, the second interface is also up. And then we'll add a description. The description, you can add it at the beginning, before you assign an IP address, or you can do it after assigning an IP address. It's not gonna change anything. So I will say this is the gateway for VLAN 10. Yeah. And then I will move to interface gig 0/2. I will set a description first. I will say this is the gateway for VLAN 20. Yeah. And then I'm gonna add an IP address 192.168.20.255.255.0. So no shutdown. And you could see the third interface is also up. All right. So what are we going to do now? So now that we've configured each gateway for each VLAN, I'll assign an IP address to the end devices and see if the ping can be successful. Let me save my configuration and then move to the first VLAN where I'm going to assign an IP address. So the IP address, I'll take 192.168.1, 5.2, because .1 has already been used for the gateway. Sorry, I'll have something like this. Sorry, the .1 is already been used. .1 is already been used, so it will be .2 over here, and then I'll use .1 as a gateway. You see, that's how we're having this message. This address is already used in the network. We can't use it. So we are done. Move to the second device. We are also going to do the same thing. .3. Then we add the gateway. So this one is done. Then move to this side. It's going to be 10.2 and then it will be 10.1 because that is the gateway. Then we move to the second device, the 3.1 is a gateway. Move to this side, we have 20.2, and then we have 20.1. So we move to this, the second device. All right, so come here, 3, and then that's 1. All right, so now that we've assigned an IP addresses to all the end devices, what we are going to do is now ping. So I'll come to this side. So I'll ping 192.168.10.2. See if the ping is gonna be successful. Yeah, the ping is actually working. I can also ping 192.168.30.3. It's also gonna work. So let's see something like this. All right, it's also working. It means what? It means all the 3 VLANs can now communicate, but the 3 VLANs are separated network. So if there's a communication just for this particular VLAN, and when when ports get flooded, it's not gonna affect the VLAN 10, neither VLAN 20. So if there's also a communication in VLAN 20, it's not going to affect the rest of the VLAN. It is just focus on the VLAN 20. So this one will actually avoid having the network congestion and also the usage of the device resources such as CPU, bandwidth, and the storage. Because when all the devices are connected to the native VLAN, which is the VLAN 1, and there is a fresh communication when the ARP the ARP frame are being generated, and all the ports actually get flooded, right? And then if all the ports get flooded, it's gonna affect the performance because the switch has to process all the ARP requests and then try to figure out what are the destination IP addresses. But then when you've segmented your network, it just affects the particular VLAN which is involved, unless the communication is between 2 VLANs. But if the communication is just within VLAN, only the ports of the VLANs get flooded. So this is what you gotta understand with the inter-VLAN communication. So in the next video, or in the upcoming videos, I will explain how we can configure the router on stick. So instead of using 3 different links over here, we are just going to use 1 link, and then we'll make sure that link is being used by the VLANs we are going to create, because this does not actually look nice, especially when it comes to production environment. We don't expect 4, 5, or 10 links to come from the switch toward the router. Because of the VLANs we are running, we just wanna make sure things are neat and then well placed, whereby we can just have 1 link and then our link is doing all the things, right? Yeah. So thanks for watching. I hope this video has been helpful. If it has been helpful, please subscribe to the channel, like this video, and also share the video to the maximum. Once again, thanks for watching. I will see you in the next video.